My role in this project is essentially that of chief engineer. The project is led by a number of PIs, including geologists, biologists, chemists, but my specific role is as the lead engineer. I'm responsible for all the engineering design of the autonomous underwater vehicles and the towed sled that we will be deploying on this expedition. We think about what we're setting out to do. Our basic goal is to go out with 4 different platforms: a CTD, a towed vehicle called Camper, and 2 AUVs called Jaguar and Puma, and to try to use them in concert to figure out more about hydrothermal vents in the Arctic Ocean. Often it takes people months to find a hydrothermal vent. In open waters, there are several expeditions who've gone with the same kind of clues that we're going to in the Arctic and spent a month with a ship, an ROV, a remotely operated vehicle, and an AUV and not found the vent. And so it's hard enough in open water. To try and do this under ice in the Arctic is way, way harder. So the Arctic is very, very different from working in the open ocean. One of the most fundamental differences is usually if we have any kind of underwater robot, we always make it slightly positively buoyant. So if anything goes wrong with it, it shuts itself off and drifts slowly to the surface. However, in the Arctic, we can't quite do that, because if we were to shut the vehicle off and let it drift to the surface, it would come in under some ice, and we may not be able to recover it. And we have a saying in the underwater world: if the number of recoveries is equal to the number of deployments, you're having a good day, otherwise you're having a really bad day. The most important and the most basic vehicle we'll have is something called a CTT, in a rotozet. So a CTD is the most common instrument used for oceanographic work. CTD stands for conductivity, temperature, and depth measurements. Because the first thing we'll probably do when we get to a site is deploy the CTD. The CTD will give us a rough idea of where the plume is. It is only after the CTD has identified the fact that there is a plume will we send down our autonomous underwater vehicles. These are basically robots that are completely pre-programmed. We pre-program them on board the ship, we deploy them, they have no tether or anything connecting them to the ship, and they go do their mission, and we're talking to them a little bit acoustically, but essentially they are pre-programmed. So those are the 2 vehicles we have in that class. One is called Puma, which stands for Plume Mapper. It's a vehicle which is designed to go search for the hydrothermal vent plume so that we can actually localize where these hydrothermal vents are using Puma. And the suite of sensors that you put on a vehicle like that are mostly to do with chemistry and temperature, so that it can quickly localize the plume, first find it and then localize it, so that we can then eventually move in with the second vehicle, which is called Jaguar, which stands for just another grand underwater autonomous research vehicle. And that vehicle is designed to actually do mapping, to take pictures, to make sonar maps of a site that has been identified with the Plume Mapper. Once these 2 vehicles work in concert to locate a site and actually map it out, then we will also move to our 3rd vehicle, which is a towed vehicle. It's a little bit like a toy on a string. In this case, this vehicle is called Camper. Camper stands for the camera and sampling sled. And the idea was, just as it says, the camera is actually what we use to find the hydrothermal vent organisms, and the sampler is what we use to actually sample, to bring back samples of biological and geological samples from the hydrothermal vents. Yes, it's very risky. Yes, we have a strong chance of failure, where failure may be defined as losing a couple of vehicles and not getting enough data. But we also, I believe, have a strong chance of success in terms of actually going out, learning something about these hydrothermal vents, and maybe sampling some of them. And given the risks and the returns, we felt that this was worth pursuing, and that's what we're doing.
This podcast was produced by the Woods Hole Oceanographic Institution, with funding from the National Science Foundation. For more information, visit us on the web at polardiscovery.whoi.edu.